One method for solving this type of equation would be to try to make the right side of this equation be just one fraction so that we could cross multiply. If we wanted to do that, we would have to get common denominators and then simplify the right side of the equation. Then we would have fraction equals fraction. Then we could cross multiply. Does that sound like a lot of work?
Yes.
Okay. There is a shortcut method that involves making the fractions go away. Does that sound appealing to you?
Yes.
Okay. So the first step is to factor the denominator, and I'm going to add the note if necessary. Sometimes the denominators are already as simple as they can be and they don't require factoring. I'm going to add a second step, step 1b, spread out your work. So I'm going to write 2x over x plus 3. Give myself some space, equals 1. Give myself some space. Subtraction tends to be a bear, so I'm going to suggest that you change it to plus a negative. So this is going to be plus a negative 6 over x plus 3. It's going to be easier for you if you attach that negative to whatever comes next. So just change it to plus a negative. Okay, to get rid of these fractions, we are going to multiply every single term by the same thing. When you have an equation like 2x plus 4 equals 10, if I were to divide, could you divide each of those terms by 2? If you divide everything by 2, you would get x plus 2 equals 5. That's still valid. You can multiply every single term by the same thing. You can divide every single term by the same thing. So as long as you are multiplying or dividing every single term by the same thing, you're good. That's the strategy that we're going to use. We are going to multiply everything by x plus 3. And I know it kind of looks like I'm making this as an exponent. It's not an exponent. I'm multiplying. I'm just kind of getting it shoved in there. You'll see. Now, in each term, I call this the cancel dance. I don't actually have a dance for it, unfortunately. I'm hoping one of you will help me in making a dance for the cancel dance. But the cancel dance is, in this first term, we now have a factor of x plus 3 on the top and the bottom. They cancel, leaving us with simply 2x equals. The next one isn't a fraction, so we have 1 times x plus 3, which if we distribute is still just going to be x plus 3. The next term is another fraction, and we have a factor of x plus 3 in the bottom and on the top. They cancel, leaving us with a negative 6. Is this an equation that we can now combine like terms and solve? Yeah. So this is 2x equals x minus 3. I would subtract x on both sides to get x equals negative 3. So the strategy is multiply every single term by the denominators, because then those denominators will cancel out and you're left with an equation that doesn't involve fractions, which is much easier to solve. Now, the last step, whoops, didn't mean to move it. The last step says check the answer. This is an important step. Let's take the answer x equals negative 3 and try plugging it into the denominators of the original problem. What happens when you put negative 3 into the denominators? You get 0. Can you have a denominator of 0? No. So this solution is actually what? So the solution x equals negative 3 is an extraneous solution. And since the only solution is an extraneous solution, your final answer is no solutions. This particular equation has no possible solutions. Okay, I'm going to draw a line so I have as much room as possible for number 4. Number 4, we're going to start by factoring any denominators that need to be factored and spreading out our work. So we have 3x minus 2 over x minus 2. Spread it out equals 6 over, how do we factor x squared minus 4? X plus 2, x minus 2. And then spread it out, plus 1. We need to think about what are the denominators. I see x minus 2. I see x plus 2. It doesn't matter that x minus 2 is in there twice. If it's in there one or more times, we want to multiply by that. We don't multiply by it more than once, just once. So I'm going to multiply everything by x plus 2, x minus 2. X plus 2, x minus 2. X plus 2, x minus 2. Now it's time for the cancel dance. I wish I had like fun music to go with the cancel dance. Wouldn't it be awesome if you were watching this video and all of a sudden you heard like music come on? And like, no. Yeah, I'm still recording, I know. The people listening are probably going to be like, man, she's nuts. Because I am. It's okay. I know. I know. Okay, so x minus 2 cancels in the first one. And I'm going to write this down here as 3x minus 2 times x plus 2. We are going to have to double distribute, FOIL, whatever with that. The next term, x plus 2 cancels, x minus 2 cancels. We're left with simply 6. And the last one, thankfully it's 1 times all of these because 1 times anything is whatever you're multiplying by. So this is going to be x plus 2 times x minus 2, which you can double distribute, FOIL, whatever. So take a moment. I'm going to pause the video. So pause the video. Take a moment and double distribute on the left, FOIL, whatever you call it. Distribute on the right. Try to combine your like terms, and then we'll see what we need to do. Once you have distributed everything and combined like terms, because we see x squared and x in the same equation, we need to get one side equal to 0 so that we can factor and solve. So I'm going to subtract x squared on both sides and subtract 2 on both sides. Now you might be thinking, oh man, I don't know how to factor this. There's a 2 in front of the x squared. Well, you do know how to factor something that has a 2 in front of it. You've just forgotten. But good news, we can make the 2 go away. What do you notice about all 3 terms? They're all even, so we can divide everything. This is the same theory for how we got here in the first place. If you divide every single term by the same thing, the equation is still valid. So we have x squared plus 2x minus 3 equals 0. That can be easily factored. It would have to be 1 and 3. The 3 needs to be positive to make it be positive 2. The 1 needs to be negative. So our solutions are positive 1 and negative 3. Now let's look back at our original problem. If we plug 1 into our original problem, is it going to make either of the denominators equal 0? No. If we plug negative 3 in, is it going to make a denominator equal 0? No, so both of them are solutions. We can say that these are both solutions to this equation. Our first step is to factor any denominators that need to be factored and to spread our work out so that we have space to work. Because if you're trying to shove things into this tiny little space, you're going to make mistakes just because your work is messy. So I've got 5 over, I can't factor 2x plus 3 anymore, so that's good. Spread my work out, plus 4 over 2x minus 3. All right, 4x squared minus 9. Now, I will not give you a problem quite like this on the test because you should remember how to factor 4x squared minus 9, but just in case you don't remember, I will try to give you easy factoring problems on the test. This is a difference of two squares. It factors into 2x plus 3, 2x minus 3. 4x squared, if you square root that, you get 2x. The square root of 9 is 3, so because it's the difference of two squares, 2x plus 3, 2x minus 3. Now, what are the distinct denominators? 2x plus 3 and 2x minus 3. Doesn't matter if they're repeated, as long as you have a 2x plus 3 somewhere in the denominator and a 2x minus 3 somewhere in the denominator, you need to multiply by that. So we're multiplying all terms by 2x plus 3, 2x minus 3. Okay, on your own, I would like you to do the cancel dance, see what you have left, combine your like terms, and see what you can solve. So go, try this on your own. So after you cancel things out, you end up with this stuff, and then you need to distribute, combine your like terms. Once you combine all your like terms, you end up with this equation, 18x minus 3 equals 14x plus 3. Solve that equation, you end up getting 6 divided by 4, which is 3/2 or 1.5 if you want to use your calculator. Now, when I check 3/2 in the denominators, the one that I'm the most concerned about is 2x minus 3. If I plug this in to 2x minus 3, 2 times 3/2 is 3, and 3 minus 3 is 0. If you want to check this in your calculator, you can use 1.5 to check it. So 2 times 1.5 plus 3, not 0. 2 times 1.5 minus 3, you get 0. So this denominator is the suspect denominator that makes this solution not work. So our final answer is no solutions.